Hi, this is Proude and welcome to another tutorial for Hayate 3. This time we are going to create a minigame and we're using Attractors. Let's take a look. So what we got here is start point and a target point, and we can move these spheres here, and they're going to attract these particles, move them around a bit, and once these particles hit the collider here, another particle system is going to emit another stream of particles, and the same with this one here. And if you move this around, you can see the sphere here is getting bigger, and we won. That's basically it. Okay, let's start from scratch. Create a new scene, and let's delete all of that here. And yeah, let's set up our scene here. I'm going to make this dark and create the basic level here. I'm using the very basic primitives so everybody can follow. With it plain. So we're making a 2D game, so I'm going to place all the entities on the z-axis to 0. I'm going to start with this as well. Make this 0 all, and let's create a new material for the walls. I'm going to call this wall material. I'm going to make this diffuse is good, make it red, and drag and drop it on top of this object here. So we don't need so much depth, so I'm going to make this much smaller. Oh, Z is okay. Move this down a little bit, make it wider. That looks good. I'm going to duplicate it. Put in some correct values here. This a bit smaller. Yeah, about that is good. So I'm just going to create the basic level design here that we're going to use in this game, just as you've seen before. That's too much. Create the level bounds. 80 degrees. Now let's add a point light so we can see something. I'm just going to put this in the center, make it a bit brighter, bigger, maybe not that big. Reposition this. Okay, now let's create some more walls. Use this cube here. Again, drag and drop the material. Position this to 0 again. That looks good. Maybe not that high. Move down. This to the other side, move up, maybe make it a bit more slim. Okay, this looks good to me, I think. Now let's create another 3D object, a sphere, which is going to be our target. I'm going to call this target. Make sure that the position is Z. I'm going to set this about here, and yeah, I think that's it for our level. We're going to take this later. This will be important for the game logic. Now let's create another particle system and add Hayate to it. So what we want to do is create a stream of particles that is going to move downwards is it? 0 again. So we have everything on a plane here. Okay, now let's add another material for this particle emitter. I'm going to use the magic scene again, glow sphere, and now let's start with the editing of the particle system. 5 seconds lifetime is okay, speed of 5 is also okay, maybe the size, I'm going to set it to 0.1 to 0.5. 0.5, and let's emit more particles, about 5,000 max particles and maybe 250 particles per second. And I'm going to enable, you see the stream is being interrupted, so it's hitting the max particle, so I'm going to reduce this amount here to 150. Let's see, yeah, looks good. Next thing, I'm going to enable collision with world, and now it starts to bounce. So I think I'm going to increase the lifetime loss to, let's say, 0.95, so it gets destroyed almost immediately. Let's see, set this to world so we can move it around. Yeah, it gets deleted immediately, so we basically can set it to 1. I think I'll make this a bit smaller, so we have it a bit easier to let our particles fly around here. Okay. And also I think I'm going to increase the radius of the cone emitter a bit, so we have a kind of a wider particle stream. Okay. Now let's start with some scripts. What we want to do is we want to create another particle emitter, particle system that uses the attractors to suck in all these particles, and when these particles hit a collider, so basically they reach the center of the emitter, then we want the new particle system to emit those particles again, but into a different direction. And we're going to use the on-particle collision event by Unity, and I think this is Unity 4.5 feature, so everyone using an older Unity version, I'm sorry, you can participate here, but you could also use the trial version. I don't think this is a pro feature. Okay, let's start by creating a new script game. Create new C# script. I'm going to use this, call this mirror particles. And let's open this up. Excuse me. So, but first, let's add just a little bit turbulence here before I forget it. Maybe 2, 3. To make these particles move a bit around and animate it. Yeah, that looks kind of nice. Okay. So what we want to do now is get the particle collision going on. So we're going to use the on-particle collision event. And we need to enter the game object as a parameter here. So you can take a look at the Unity documentation to get more info on this, but I'm going to explain this anyways here. Okay, so the first thing we need is the safe length of the particle collision event size array. So we're going to declare a new integer, which is called safe length, which equals system dot save collision event size, and then check if the collision event wait a second. Before we do that, we need to declare a new array which contains all the particle collision events. This is part of the particle system namespace. And it is an array. Particle system dot collision event, and let's start with maybe 16. We're going to override this later with the safe length integer here. So we have to check if the collision event length, which I didn't name here, so the collision event that length is less than safe length, then we have to declare a new collision event array. And we are going to make this as long as safe length, just like this. Okay, and now we have to get the amount of particles, since we want to emit the same amount of particles in the new emitter as we received from the old emitter. So let's create a new integer, num collision events, and this is going to be inside the particle system this script is attached to, and we're going to get the collision events. So no, that's not like this. A new game object. So like this, you get the game object of the collision event, which is the other particle system, and we need the collision events. We need to get those. Okay, now let's set up some tags here to continue. Now this is going to be our target, so just tag it as a target. If you don't have this already in here, if you don't know how, just go to add tag and create a new tag here. Go back and set it to target, and then we're going to, since this is the start particle system, we don't need to tag this. We're going to, but instead we're going to duplicate it, rotate it. So I think this direction should be okay. We can change that later. I'm going to tag this mirror. So so we need to get this, this is correct here. I just made a little mistake. We need to tell the particle system which game object contains the particle emitter, and get the collision events here. We got them here we declared them in this part here, but this is going to write our collision events into our collision event array, and this returns the amount of the length of the array, basically the amount of particles that hit our collider. So next up, let's see if the collider we hit is tagged mirror. Dot tag equals. So if we are hitting a mirror and not a wall or anything else, we do this. We have to emit particles. And the amount is the num collision event integer here, which is basically the amount of particles that hit our mirror. So let's go back, and we need to add, let's see, some errors here. Collision event does not exist in the current context. So let's see. We don't need an S here. Or no, we're just going to rename this because this is an array. So maybe get this here. Let's see. And collision event does not exist in the current context. Okay, where is it? S and S. So now we got the arrays correct. Right. So we need to add a new collider here. I'm going to add a sphere collider. Whoa, that's big. I'm going to center it and make it a lot smaller. Maybe 0.3. 0.3 should be okay. And now let's drag and drop the script on the start emitter here. Where is it? Here it is. So this is going to execute the this is going to emit particles when, so basically if a particle of this emitter hits this emitter, it's going to tell this emitter to emit more particles by the amount of collision events here. So this does not need to emit anything right now because this is going to emit only if it's hit by a particle. And let's see what happens. Nothing yet. Did I set up the positions correctly and the oh yeah, and we have to enable send collision message in order to make it work. This function here only gets called when send collision message is enabled. So just quickly rename this. Call this start. I'm going to call this mirror 1. Okay, let's play again. Don't need to maximize it. Go back. Okay, at least it's hitting something. Maybe we make this emitter a bit bigger. 0.6 maybe. Okay, this looks good. So now let's see, why is this thing not emitting anything? Just reset this again. Go back to the script. Let's see. Okay, when this gets called, so the game object that was hit is going to be inserted here as a parameter. Then we check the save length, get the collision events, and then going to tell this particle system to emit the amount of particles. Let's see if it's working. Hit particles plus num collision events. Okay, let's see what this does. Okay, it is colliding with the emitter, and you already get the log. Hit particles, so we can remove this again. And then let's see what happens when we play the scene. Nothing. Yeah, the send collision message has been reset, so as you can see, just make sure that this is enabled so this on particle collision event gets called. Back, enable. So now what we want to do is we want to give this some kind of radius, some cool effect. So I'm going to add an attractor here in the start emitter. I'm going to parent this to the first mirror, set it to 0, 0, and rotation doesn't matter. I'm going to increase this here a bit, maybe to 20 and 3. You can already see that this is going to attract something. At least it should. Yeah, it's already attracting. So if you move this around and these particles are closing in, they're going to hit this object. So I think the collider here is too big now that these particles try to follow this. And let's move this a bit closer. Yeah. Now what we want to do is we don't want these particles to just be affected just a little bit. So what we can do is we could increase the attractor's strength, but this only would make these particles faster. Let's set it to 80 maybe. So if you don't want that, then we should reduce the velocity of a lifetime of these particles here. Limit velocity of a lifetime. Since we start with 5, I think we're going to use a curve. Start with 5 here, and then just become slower over time. So we create something like a vortex effect here. Let's see what this looks like. Yeah, much better. Maybe we shouldn't dampen it too much. Let's see, 0.8, 0.5 maybe. Yeah, just got a little vortex here, which is actually pretty nice. Just some visual style. Let's try what happens if we move it around. Yeah, these particles get sucked in just as we wanted. So this game is about getting these particles from the source to the target. So the next thing we need to do is we need to get another mirror. So I'm just going to duplicate this. Call this mirror 2. Move this over here, and I think this time the direction of this image is going to be downwards. We have to create a new attractor here. Enable attractors in the first mirror object, add a new one, and drag and drop it and parent it to the mirror 2. Then again we need to reset the scale, position and rotation. And I think this time I'm going to make this attractor a bit bigger. No, where is it? It's here. We are going to make it 5, attenuation of 5 and a strength of 40 maybe. Let's see how this looks like. Yeah, it's okay, but these particles again are too fast, so we need to limit the force of a lifetime here as well. Make a curve. I'm going to set it to 5 again. This time I'm going to add an extra keyframe so that it gets slower only at the end of its lifetime. I'm going to dampen it to maybe use 0.8 here. See what this does. Yeah. Okay, this looks good to me. Now this again does not emit any particles, so we check the collision event again and switch it on. So what happens if we move this around? Yeah, works perfectly. So let's go back to the scene view, and the next thing we want to do is make this the collider and the attenuation visible in game mode. So I'm going to create a new sphere, and let's see, I'm going to also create a new material. I'm calling this sphere. I'm using particles additive. Let's see, where did it go? Here. Reposition it to 0, 0, 0. Drag and drop the material on top of it, and I think we don't need so much opacity. Okay, now I'm going to drag and drop it onto the first mirror, reset it again, and then change the size to the attractor. So the first attractor has an attenuation of 3, so we got to set this sphere to 6 in scale to make it fit, because the attenuation is the radius and not the diameter. So I'm going to duplicate this again and make this smaller, maybe the same size of the collider. So let's do the same for the other mirror. Reposition it to 0, 0, 0. Rotation doesn't matter. And this time we're going to have to set this to 10, because the attenuation is set to 5 on this emitter here. Okay. So the next thing we want to do is we want to let this to move these emitters in game view, and not just moving around the game objects. Yeah, but first the thing I see here is these spheres already have a collider. We don't need that. We don't need those, so we are going to remove them. Just remove component, and now they are gone. And this collider here, does it have a collider? Let's see. Yeah, it does, and it's tagged to mirror. So let's create a new script that controls the position of these spheres here. And I think I'm going to call this game, and I'm going to attach it to the main camera. Just drag and drop it on top, open it up. Where did it go? Here. So what we need is the update function. We're going to raycast from the mouse position towards the sphere collider. So but first we need to check if there is some input. So if we press the left mouse button, input dot get mouse button down, and 0 is the left mouse button here, we're going to raycast. So what we need for that, we need a new ray, and this ray will be from this camera screen point to ray, and we're going to input the mouse position. So we use input dot mouse position, and we also need to raycast it. Ray hit, new raycast hit, and then we're going to raycast. So if the raycasts, so if physics dot raycast, and then we have to put in our ray in here, our raycast hit, our ray hit, which needs the out parameter here, and then we have to tell it how far it's going to test into camera view direction. So I'm just going to put in 50 here, which should be sufficient. So if the raycast hits something, we have to test it if it's a mirror, because we only are able to move mirrors. So if the ray hit dot transform dot tag equals mirror, so if the object we hit is tagged mirror, we're going to save this transform into a selection. So let's create a new transform. We make it private because we don't have to use it somewhere else. I'm going to call this selection. So I'm going to set the selection to rayHit.transform. Okay. So this is what happens if you actually hit the mouse button, and this is only fired once, exactly when you first click the button. So if we want to move the button, move the selection as long as the mouse button is pressed, we're going to have to use the input get mouse button, which fires on every frame. So if we click and hold, then this here will be called once, and this here will be called on every frame. So in this part here, we're going to actually move the option, the selection. So let's first check if we actually have a selection. So if selection is not null, let's get a new vector. So what we want to do is we want to move the translate the camera position, the screen position, to world position, and this is how you can do it. So we create a new vector and create a new vector position pos equals camera dot screen screen to world point, and now we have to input the position at which our mouse has been clicked. But this time we also have to define the depth at which we want to translate this point. So we can't just use the mouse position, which is actually a vector 3, but the z position is empty. So we have to create a new vector, vector 3, and then we're going to input here the mouse position dot x, the mouse position dot y, and let's test how far. Just enter some arbitrary value about the depth of the distance of the camera to the z axis, to z0. Let's check this out here. 0 is here and the camera is about 10, so let's try 10. You can also make the script much nicer. I'm just trying to get this this game to work. So yeah, hope you don't mind the crazy programming that's going on here right now. Okay, and then I'm going to reset the z to 0 because we only want to move it in x and y direction. And now I'm going to assign this to the selection. So now we got one last thing we have to do is because what happens if we want to click on another object and select this and move this around. So we have to unassign selection, and this is going to happen on input.get mouse button up, which is basically just the opposite to this function here. This will be fired as soon as you release the left mouse button. So get mouse input.get mouse button up 0, so which means if you just release it, if selection is not null. So if we don't have no selection, we don't need to execute this. But then we set it to let's see if this compiles. Looks good. Play, and let's see, can we move it? Yes, we can. If we release, everything is fine. Can we move the other one? Also very nice. Now we have our objects here. Do the other objects move? No, perfect. This is exactly how we want this to be. So let's see. In the game, of course, you don't want to make this too easy here. So I guess you could just reposition this, or maybe add a UI to tell the player which mirror objects he can use. So I guess you just have to let him find out how this is going to work. Let's see, and yeah, move this around and you got this going, and the other object as well. It is not emitting again. Why is that so? Let's see. Collision. Send collision message. Make sure this is checked. I'm making so many mistakes here, I'm sorry. I hope you get the gist of this. Also, this is not emitting again, so what's going on here? Let's check this out. This object has not enabled the collision message, which is crazy because I told you guys to check this 100 times, and I'm always making the mistake to forget to enable this again. But this time, perfect, it's working just fine. Okay, now the final thing we want to do here is to create some kind of win functionality. So the target needs to do something in order to understand that you're just hitting the correct thing. So I'm going to create a new material here to make this a bit more visible. Material, I'm going to call this target material, and I'm going to make this green, drag and drop it onto the target, and I'm also going to make the material alpha blended. Oh no, I'm going to make it additive. Why is it not green anymore? Here we go. Finally. So what we want to do next is we want to add the target functionality to the game. So I'm just going to add a new game object variable here. I'm going to make it public because I'm going to assign it in the inspector. I'm going to call this target. So and a boolean, call this won the game, which is going to be true if we won the game, so we can check later if we actually won the game. And maybe if you like, could also just add some functionality to save high scores, or get to the next level when you won the game, of course. So let's see. I think I'm going to use the transform scale because this is very obvious to see. So let's see, if the target dot local scale dot axis bigger or equal than 5. I'm only testing the x value because we are going to scale this uniformly. So if this is bigger than 5, we're going to win the game, and we're going to end the game. So I'm just going to pause it here. I know it's a cheap trick, but I think you have a lot of ideas how to improve this. And if we if the local scale is something between the original scale and 5, we're going to lerp it, so animate it in a way that it shrinks back to its original size. So to do this, I'm going to use this vector 3 vector 3.lerp just to make it a bit more difficult to win. So we're going to use the local scale as our current position, and we want to lerp it to vector 3.1, so which is the original 111 scale. And then we have to define the speed, and I think 5 times time dot delta time should be fast enough. So now that we got this going, let's see, we need to add something to the mirror particles here in order to make it bigger, of course. So if the particles hit a game object that is tagged target, we're going to add a specific amount of scale. So we're going to increase it. I'm going to call this add scale, and this is going to be the original scale of the object. Because you can't directly assign, you can't just add a vector to a game object to transform. You have to define a new vector before in C#. And I'm going to set the transform.local scale to the add scale plus, and now we have to we use the num collision events, create a new vector 3, and we're going to add num collisions, and I think we have so many particles that would make the spheres so crazy big, so that we divide it by, let's say, 10 on each axis here, and I think this should be good. Let's check it out. Oh, we get a bug here. Time Unity engine property or index. It's read only. Of course, we can't set the time.time. We have to use. I wanted to actually use the time scale here to stop the time, and not set the time. It would be silly. And the error is gone. Let's see if it's working. Not really. Yeah, I forgot to assign our target here. Of course, we have to do that. We go to main camera and drag and drop our target in here. And by the way, let's make this private. We don't need to see this in the inspector. And now everything should work fine. Yeah, no errors. Can we move it? Yes, we can. Now let's move this around. See, yeah, it's hitting, it's getting bigger, and I think we need to reposition this a bit to make this go up to 5 scale. Maybe I was a bit too optimistic with, here we go, it stopped. So maybe, yeah, one last thing I think we should do here is to actually display a message, so that you know that you won the game. It's not just froze. So let's create a new GUI label, but we're only going to display this if we actually won the game. So I'm going to create a new GUI.label. We have to define a rectangle. Don't write it, it's a rect. And I'm going to put this in the center of the screen, so I'm using screen.width divided by 2, and then screen.height divided by 2. And I think the label is going to be 100 pixels wide and 40 pixels high. And the text will be "You win the game." Nice. Maybe yeah, I think this should be good. Just normal game loop. Play, start, move these spheres around. See how this is going. Is it going to be bigger? Yeah, it's starting to. I think this is a bit too difficult. Maybe. I think I'm going to reduce the speed at which it gets smaller, because this is yeah, put it to 5. This is too difficult. I think someone who freshly starts this game doesn't really understand what's going on here. Okay, let's see. And yes, we got it. You win the game. Okay. There are a lot of things we could improve here. First of all, you could make it more difficult by adding, let's say, another attractor and setting its value to -40, and then place it somewhere here to make it more difficult. Of course, this is up to you what you actually want to create. Why isn't this working? I created this in the... Did I? No, this is 1, this is 2. This should be working. It's inside there, and I think it's just not strong enough. I'm going to make it I'm just going to make it stronger. Let's see. Yes, of course, it was not strong enough. So let's see. Is it still possible to win the game? Yeah. Making a game is very difficult. Depending on the style of your game. And I think you can create much better games with Hayate, instead of just created this level here quickly to demonstrate the new features. And I hope you liked it, and if you have any requests about tutorials, send an email to support@maxproude.com, and of course you can always contact me anything else as well. If you have suggestions, if you want a new feature in here, if you have other questions, please don't hesitate. And I hope you liked it. See you next time. Bye bye.